Pleasure to be here. Very excited to be the first presenter this morning. So always an honor. Always an honor. As was just mentioned, I'm going to be presenting on the development of a new driveline lubricant for transmission, specifically Eaton transmission. Eaton has developed a new transmission called the FAS, and the FAS is what they call a dry sump transmission. It requires essentially a new kind of fluid that provides enhanced benefits over the existing synthetic transmission fluid and falls in with a lot of the trends that we're seeing in the market. Smaller transmissions, less fluid, higher torques, and as a result, higher temperatures. And so some of the design aspects of this fluid are to reduce operating temperatures, to provide better fuel efficiency, and maintain or improve durability. BASF and Eaton have had a relationship for somewhere on the order of about 30 years. And we are a key partner to Eaton in their development of their transmission fluids. They look to BASF to help provide improved products, to make their products better, and to enhance their customers' experience. So what we're going to talk about today, I'm going to give a little background of some of the drivers. As I said, legislation is key to a lot of the changes that occur in our market. We're going to talk a little about the specifications and then move into some of the more critical factors such as temperature reduction and fuel efficiency. The presentation is a little bit technical, but since I'm a commercial person, I have to add a little commercial aspect to it, and I think we'll all be able to understand very easily. So let me give a little background. The truck market is evolving. There are new government standards in the US, in Europe, in South America. We have, in 2010, a presidential order that requested improved fuel efficiency for medium and heavy-duty trucks. In the US, that has been reserved for light-duty vehicles, but now, like the rest of the world, greenhouse gas has become a larger issue, and as a result, our governmental bodies, NHTSA and the EPA, have gotten together to create a new regulation. That new regulation took effect, or took form in 2011. The OEMs were given about a year and a half to feedback through about 2012 or 2013. And then voluntary enforcement took place in 2014. So it was an opportunity for the OEMs to introduce new technologies that would help promote improvement in fuel efficiency and reductions in greenhouse gases. In 2017, those regulations will become mandatory, and we will see requirements put on heavy-duty and medium-duty trucks. In addition, we've seen fleet sophistication increase, and there is an ever-increasing need for a lower total cost of ownership. So many of the fleets find it very difficult to pass on rising costs, and they're looking for ways, especially in light of higher fuel prices, to find alternative technologies to help them reduce their overall total cost of operations. And some of those things are fuel efficiency, lower maintenance costs, and higher operation times. So, as I had mentioned, this fluid was developed in conjunction with Eaton, and the specification that they call it is PS 386. So this is their performance specification, PS 386. And PS 386 designates a new fluid for the existing transmissions. So all of the transmissions that they currently have out there, so it's backwards serviceable, as well as the new FAS transmission, which is this dry sump transmission. And in addition to being dry sump, has no cooler, as coolers tend to produce the greatest warranty claims. And so a key when you remove the cooler is improved heat management. And so this fluid had to produce or allow the transmission to operate in its current conditions, but generating less heat. Also, in addition, fuel economy is key. A lot of the OEMs are vertically integrated. They're producing their own transmissions, they're producing their own axles, and as a result, Eaton finds themselves in a position where they have greater competition in their market, not only in North America, but in other parts of the world. And so part of the key is to drive fuel efficiency to a greater level and hence be more competitive in the market. Of course, durability is the #1 key aspect of any formulation and any engineering design, and hence improved durability is very important. Ecologically friendly, this is a sustainable effort that BASF and Eaton participate in, and I know being green is a very important thing in all regions and all markets at this point. And so it's very important for our products to leave a smaller carbon footprint on the market. And so through better fuel efficiency, we see things like reduced CO2, which is, like I said, important in most markets. And then that backward serviceability. So Eaton is looking at raising the bar and utilizing a new fluid to help them move through into new transmission designs that not only improve their competitiveness, but improve the market overall. So if we take a look at, we touched on the background. Now we're talking about confirming the specification. What does the specification look like and what's required? So some of the items that are very key to this new specification are compatibility with the existing fluids, improved shear stability, and through improved shear stability, we see a benefit not only to the customer, but to durability, because we can blend the viscosity to a different level, we can improve fuel economy, and the product can stay in grade for a longer period of time, which may, in the future, allow Eaton to promote longer extended drain intervals. In addition, we can increase oxidative stability, because if we have longer drain intervals, we need a product that can remain in the transmission for a longer period of time. And we need that increased durability. So improved scuffing resistance, improved gear protection, and of course improved micro-pitting. So the physical properties, the viscosity, the flash points, the densities, those are really no issue. We were able to develop that very easily. The compatibility issue, again, making it compatible with existing and new seal materials, making it compatible with potentially increased amounts of water and other fluids, whether they be synthetic or non-synthetic. A little more challenging, but again, check the box on that one. And then we look at the performance properties: shear stability, oxidative stability, that scuffing resistance, micro-pitting, and of course fuel economy. So what do the physical properties look like? If we reduce Brookfield viscosity, the graph on the left, this allows for better pumpability at low temperature. This allows for better shiftability. And as I had mentioned, the FAS transmission is a dry sump transmission. And part of the way that they get that is that they use a forced injection pump system to get the fluid to the key areas of the transmission, reducing churning losses. Well, given the way that the oil needs to get to the gears and how critical that is to its lubrication, it's very important that fluid can pump at all temperatures. In addition, shear stability is significantly improved by approximately 50%. This allows blending flexibility, improved fuel economy, and also better bearing and gear protection throughout the serviceability of the transmission. Now the new specification, PS 386, has several scuffing tests in it. One of them is an FCG test, and in the specification there are at least 2 FCG tests that are called out. One of them is on the A10 gears and the 16.6 meters per second, so double speed FCG. And the goal there was to have a load stage 7 pass. And on the FCG scuffing standard test, the A3 or A8.390, we were looking for 11 stage pass. Being that these are not axle fluids, but transmission fluids, having a very high FCG performance and very good oxidative performance, which I'll show shortly, is part of the challenge and part of the expertise that our technical people have put into this. Now this shows the L60 test. Now our chemists have correlated in applications with respect to Eaton and their transmissions, a 300-hour L60 being equivalent to a 500,000 plus mile drain interval. And so it's very important to have very clean components and resist the oxidation and the viscosity in grease that you might normally see with alternative non-approved products. And you can see from the front box, the back box, and the gears that we were able to achieve this excellent oxidative stability. And the viscosity increase typically for this test at 50 hours is less than 100%. And at 300 hours we were able to achieve just below 30%. So we've addressed the compatibility issues. We've addressed the improvement in Brookfield and shear stability, and we've met that with excellent oxidative stability. Now we take a look at micropitting. And micropitting is just a fatigue effect that occurs in gears, transmission systems due to high contact stress. And there are several parts in this transmission that are subject to micropitting, and this is why this is such a critical aspect of this new specification. We see in the drive gears in the main shaft, and also on the overdrive gears in the main shaft, these are the areas of potentially high micropitting. And so when we look at field testing, these are very key issues for evaluation. So if we take a look at those gears after initial testing, both bench and fleet testing, and the fleet testing is still ongoing, but we've got fleet testing of over almost 20 million miles across the last year and a half, 2 years. So there's an extensive amount of field testing that is ongoing with this, but the bench testing that was initially run to support the field testing shows that we have absolutely no micropitting on either the counter shafts or the main shaft gears, which is, again, another requirement of Eaton's new specification, simply because the FAS transmission, this new transmission, has a different type of lubricating method, and as a result, the concern was that it could be more susceptible to conditions like micropitting. And so not having any pitting, spalling, was very key to the next generation development. Now I've got a couple older pictures here of some of the field test results that were run. Trying to get the new ones out from our technical group. But I think you can see in many cases that the performance of this product leaves the transmission in excellent shape. Here we've got the magnet at the bottom of the transmission, and you can actually see the radial parts of the magnet. It's not covered up, and this has not been wiped down in any way, shape, or form. This is the way it was taken apart. So it is exceptionally clean, and there's no iron that has been generated. So all the work that was done to look at micro-pitting, all the work was done to look at overall durability, manifests itself in excellent cleanliness and a complete lack of wear. We look at the synchronizer material. We can see that there's no caking of material, and the synchronizer material actually looks almost new. And then, of course, over here we've got seal material and the sealing surface, and these are all in excellent shape as well. And so we saw really no deterioration of the fluid across 200,000 miles and subsequently across over 500,000 miles. These are some additional pictures from another transmission. Again, exceptional cleanliness in this area. And here is the synchronizer cone, and the synchronizer cone looks to be in excellent shape, and there are no deposits, no sludge buildup, and so again, the durability, the oxidation, all of that looks to be well under control. And then finally, some pictures of some gears, some bearings, key aspects of the performance of the product. Bearing, reducing any type of friction in the bearing, extending the life of the bearing, reducing temperature, improves the overall performance and efficiency of the transmission. So now let's take a look at some of the improved efficiency, the final pillar that we're going to talk about today, and really the one that matters to most of our customers, the one that drives the fleets to a synthetic fluid over potentially a mineral fluid. So not only did we talk about the durability, but we're also going to talk about efficiency. Now efficiency, when you talk about something like that in a mechanical system, we all know that the mechanical system of a transmission or an axle is very efficient. It's already 98% efficient at steady state conditions, maybe even a little bit higher. However, it's the fluctuations that really have an impact on the fuel economy and allow us to look at 1 or 2% fuel economy improvements, fuel efficiency improvements. So what our technical team did was they started with simple bench test, MTM bench test, to look at frictional characteristics of the new fluid versus the existing fluid. Then they moved on to more expensive gear testing, FCG gear testing, FBA gear testing. Then they looked at temperature rise. Again, another pillar of the development of this product and another pillar of what Eaton needed in their development. And then finally, we took it to field test. We ran something called an SAE J1321, which in the United States is a fuel economy test that is used to evaluate the fuel economy of a complete truck. And then, of course, we reached out to a lot of the fleets that Eaton serves and asked them to run the product, not only from a durability standpoint, but also from a fuel efficiency standpoint. Looking at small changes in fuel economy really requires you to go through all of those steps so that when you get to the end, all of the data adds up and confirms the fuel economy that you eventually see. So the first thing that we did was run the MTM, the mini traction machine. This is a very simple machine. It looks at a slide roll ratio. You can see here, here's the ball, here's the disc. The ball rides on the disc in this picture. Here's the lubricant that sits there. And what you're looking for is you're looking for frictional differences in the performance of the product. And you can see in the red line where that is the existing material. And when you see lower numbers, when you see it drop from here to here, you're seeing a reduction in friction or traction. And so that gives you an indication that your formulation is headed in the right direction, that you've actually made a significant change in the performance of the product. It doesn't guarantee, however, that you will actually ever see fuel efficiency, because there is no direct correlation between the MTM and the J1321 or field testing. So you've got to do more testing. So our engineers, chemists, looked at the FEA 345 efficiency testing. And if you're familiar with the FCG 4 square test, this test has two shafts, a solid shaft and a split shaft. And the split shaft has a clutch here, and you can apply weights to it. And then you can measure both temperature rise and efficiency from the input of the torque that the motor imparts to the system. So a major target of transmission design today is higher efficiency. And of course, with higher efficiency and higher torques, there's always a concern of temperature reduction. So it's very important that as you increase the torque, that you also find a way to carry that energy away from the system in terms of efficiency and or heat. And of course, as the system becomes smaller, higher heats, lower oil capacities drive the temperature up and potentially reduce efficiency. In a system that I described, this Eaton transmission system where it is a dry sump, higher efficiency is important, but also temperature reduction is key. And so we look at the output of this FEA 345, and we can see that with the existing product, we had a temperature of 54.1 degrees C, which translated, because this is the baseline, into a certain amount of energy. The new product saw a temperature reduction, and through the calculations, saw an energy loss of about 9.1%. So an actual reduction in energy or an increase in efficiency. And so this supports the reduction that we just saw on the MTM and shows that there's an opportunity again for improved fuel efficiency. So the next step is to look at temperature reduction. So again, using the FCG machine, as we've stated, loading the unit up to, and if you recall, when we ran to a very high speed or a very severe FCG condition, we were able to get to an FCG load stage 11 pass. So we targeted stages 6, 7, and 8 to look at temperature increases. You can see here, we start the unit up at ambient temperature. We let it run up to where it levels off. We shut it down, and that's what this is. And we start it back up at the new stage, so we put more weight on it. Start it up at the new stage, let it level off, shut it down, and then do the same for load stage 8. And what you can see here is the separation between the red line and the blue line shows about a 10 degrees C reduction. So this supports what we saw in the MTM, which is reduced friction, and supports what we saw in the FEA 345. So now we've seen an improvement in efficiency, a reduction in friction, and a reduction in temperature. So now we move to the next step, actual dyno testing. And from what we, and I don't want to go into the detail here necessarily. If you have questions about it, we can talk about it after the meeting. But for time's sake, what we did was we looked at spin and torque loss. So a loaded and an unloaded system. And we looked for overall efficiency improvement in low speed, medium speed, and high speed. And what we saw was in the spin loss test, where there's no load, we saw an overall spin loss reduction versus the current reference of about 7.1% at 2 different temperatures. And when we look at the torque loss, or the loaded system, we saw an overall reduction of 7.5%. So again, more information to build on improved efficiency. More justification for someone to spend money on more expensive tests. And you can see from these graphs where we took the data, and these represent, the larger bubbles represent greater efficiency gains. You can see in low gears that we have the most efficiency at high speeds, so this is the speeds, and high torque up here. And then we have the opposite here, which represents what you would see generally in Class 8 online road haul trucking. And so again, this lines up with all the rest of the data that we've seen up to date. So then we move to the SAE J1321, which I referenced earlier. This is a fuel efficiency test that is actually on road or on track that is run to look at the overall efficiency of the complete truck relative to another truck that has a baseline fluid in it. And so the issue is we rent a truck, we then instrument the vehicle, we hire drivers, and then we run the trucks on a very specific route. And what you get from that then is that they use a very specific amount of fuel. They weigh that fuel. That fuel is only used while the truck is in test. And they take that tank off at the end, and then they weigh that fuel. And then they use that fuel for the reference and for the candidate, divide one by the other, and you get an improvement in terms of fuel economy. So if we take a look at the outcome of that J1321 testing that we ran in Texas, we can see this is the route that was run in Texas, just outside of San Antonio. We can see relative to the existing approved fluid that we were actually able to get about a 1.7% fuel economy improvement with a 98% confidence interval. We then reran that test in another fleet in the Southwest, and they came up with a 1.7% fuel economy improvement. So again, very similar. We then gave that to another fleet, and they were able to generate up to 2.5% fuel economy improvement. And finally, the fourth fleet got about approximately 1% fuel economy improvement. So all of those numbers together give a sense that we're somewhere in the 1.5, 1.6 range in fuel economy. Now there is one more set of data that is not in this presentation that I did want to mention. We just got some data back recently that showed that the combination of the new fluid with the FAS transmission provided over 4% fuel economy across 80,000 miles. And so now we've got transmission testing in the old transmissions that showed about 1.5% combined, and then in the new transmission system with the new fluid, somewhere in the order of 4% fuel economy with about a 98% fuel or confidence interval. So again, we're very confident that this new fluid, along with the transmission, will provide significant improvements in terms of fuel economy, durability, maintenance, on-road time, etc. And so, being the marketing guy, I just have to throw in this one last slide, and that is on the benefit of NTF to the customer. And what we can see here is we just did a simple calculation based on the number of miles accumulated in a year, the relative cost of fuel, and the improvement that we talk about of around 1.6%. And we can see that annually per truck, a fleet would save $733. And in the U.S., a small fleet of 100 trucks would save somewhere on the order of $73,000 a year. So given the minor cost of the fuel, minor cost of the additive system and the transmission system, you can see immediate savings to existing and new fleets in orders of magnitude higher than the cost of the food. So with that, I want to thank everybody for their attention and appreciate the time. Thank you.